Now we're going to think about how to solve problems using reference angles. So given that cosine of theta, 30, is what, and the question is, what is the cosine of 30? Based on the unit circle, hopefully you remember, it is the square root of 3 over 2. And so what would 150, cosine of 150 be? So cosine of 30 is here. The x value is square root of 3 over 2. Where would 150 be if this is 30? And why did I pick 150? Well, 150 is just 180 minus 30. So you're going up or back 30. So this angle here is 30. God, I cannot write that, sorry. And by reflection, it's the exact same x value, but it's negative. I don't even care about the y. So it's negative square root of 3 over 2. What about cosine of 210? Well, that's 180 plus 30. So it's 30 more than 180. What's the x value there? Well, by symmetry, it's the exact same x value as this, and it is still negative. I don't care about the y value. So it's a negative root 3 over 2. And finally, 330 is 360, take away 30. Go back 30. Again, same x value, except x in this case is, well, it will stay positive. So that's the square root of 3 over 2. So you see I have like a little bow tie here. Notice I always draw to the x-axis. I'm never ever going to draw to the y-axis. And these 4 different angles all refer to one another, which is why 30 is the reference angle. So the reference angle is always going to be the acute angle, the one that's in quadrant 1, and every other angle will refer to it. Okay, so in this case, if I wanted to find, if I want to know what the reference angle is here, what is this little reference angle? It's going, here's 180. So this one would be 180 minus theta. Notice the reference angle is given with a little prime symbol, okay? How about if I wanted to know this little reference angle, this little acute angle that is drawn? Well, it's going to be the entire angle theta, but then take away minus 180 degrees, just to give you that little piece. So it's going to be the entire angle take away 180. And in this quadrant, it's going to be 360 take away. So 360 take away the little reference angle. And that's how you know how to do it for all the little quadrants that you're given in. Okay, so what is the reference angle of, for example, 300? Well, let me first draw 300. 300 will be in this quadrant. Draw the triangle up to the x-axis. What is left over? Well, and I just totally did that wrong. I'm sorry, 300 is actually here. Okay, so then I'm asking if this is 300 degrees, what's left over? And so the reference angle theta would be 60, because 60 is left over. How about for 225? That's better. That's over here. If this whole angle is 225, what is the acute angle formed by this line here and the x-axis? So that's going to be 225 minus 45, which is minus 180, which is 45 degrees. Now, if I want to find the reference angle for negative 210, I would go backwards 180 and then a little more to get me to negative 210. How much more? That would be 30 degrees. So that's the reference angle here. You always make a reference angle positive. And then for the 420, you go around a full 360 degrees, and then what's left over? That's your reference angle, 60. So it's whatever is just formed by the terminal ray and your x-axis. Okay, radians, same thing. If I went backwards, pi over 7, that's actually going to be my reference angle. Always positive, so just pi over 7. 3 pi over 4, hopefully from your unit circle, you remember that that's here. What's left over? Pi over 4. Okay. You always, if it starts in radians, you end it in radians. And then 5 pi over 2, so this is 1 pi over 2, 2, 3, 4. I end up right here, and there is no way to make a right triangle, so there is none. And what about 3 radians? Well, you have to think about the fact that this is 3.14, and it's because it's pi. So 3 radians, what would be left over? It would just be 0.14. Okay, and then there's some for you to try. Let me go to the next slide. All right, now we want to figure out what these trig functions are. Like, for example, if I say, what is the tangent of 135? Now, these could be done using the unit circle, or you can do it by thinking about the sides of a, like, if, for example, the reference angle here is going to be 45 degrees. 45 degrees. This is so hard for me to write with this pen. And you could say, you know that this is a 1, 1, radical 2 triangle, but the x is -1. What would the tangent be? It would be opposite over adjacent, or 1 over -1. So the answer would just be -1. Now, the reference angle was 45, and that's how you do that. For the cosine of 210, so 210 would be here, 30 degrees left over. There's 60. This would be a 1 radical 3, because side opposite 30 is 1, side opposite 60 is radical 3, 2 triangle where the x and the y are both negative because of the quadrants. Cosecant is the reciprocal of sine, so I would find 1 over the sine of 210, which would be 1 over the sine of 210 would be opposite over hypotenuse, so -1/2, which is the same as 1 times -2 over 1. So the answer to that would be -2. Okay, I'm going to jump to secant of 90. Here's 90. No triangle here. This is 0, 1. And I just do it by saying what is 1 over the cosine of 90, which is 1 over the x value. The x value is 0. So this would be undefined. Okay, and I'll just do maybe, oh, I don't know why there's a do symbol there. That's a mistake. I'll just do maybe one of these. Where would 4 pi over 3 be? Well, that is the one that is right here, based on the unit circle. So when you take your quiz, you'll be much more proficient in that. This is a reference angle of pi over 3. Think about it. This is 4 pi over 3, and this is pi, which is 3 pi over 3. The reference angle is just pi over 3. And so that's like 60. Let me just draw that better. So that's 60, that's 30. This is going to be -1. Side opposite 60 is √3, which will be negative. And then 2. Cotangent is adjacent over opposite, reciprocal of tangent. So -1 over opposite, -√3, which is 1 over √3, which we then rationalize. And we get, running out of room, √3 over 3. Okay, so that's the idea on those kinds of problems. And finally, to work backwards, what is the angle whose tangent, or whose secant is -2? So now I'm trying to find the angle. I have the ratio. Okay, so instead of dealing with secant, I'm going to deal with cosine. And I'm just going to reciprocate this side and get cosine. And then I'm going to reciprocate this side and get -1/2. And I have to think, where is cosine -1/2? Well, cosine's my x value. Cosine, that means that it's negative. So I would draw, where are my bow ties? Remember the bow ties? Where x's are negative. That's going to be here. And I need my adjacent over my hypotenuse to be -1/2. Hypotenuse will always be positive, okay? The adjacent is going to be this -1 right here. So we have to think about which angle would this be. Well, it would be these kinds of triangles, a -1, √3, 2, or a -1, -√3, 2. Why is this one negative? It's just because it's the y value goes down. And so clearly I can see that this is a 60-degree angle, and that's a 60-degree angle because it's across from the √3's, okay? And so I can figure out what that is, or I can just know, since it's given a radians, I need to know the radian answer for that. So the radian answer for this angle, which would really be 120, is 2 pi over 3. And the radian answer for this angle, which is 180 plus 60, 240, is 4 pi over 3. Okay, I'm just going to do one more. I'll do this one right here. where is cotangent positive? Well, cotangent is x over y, or adjacent over opposite, and that means we need the x's and the y's to both be positive. So that's going to happen here and here, because really truly the x's and the y's in this quadrant are both negative, but they cancel when you divide them to be positive. So I'm going to put this over 1. I need the adjacent to be root 3 and the opposite to be 1. Likewise, I'm going to need the adjacent here to be negative root 3 and the opposite to be negative 1. And we know the hypotenuse for these triangles are 2. Well, what's the angle opposite 1? It's 30. So these are both 30. But in radians, I know that this one here is going to be pi over 6. And then this one here, remember, this is 6 pi over 6. So this angle would be 7 pi over 6. And that would be the two answers.